Okay, today let's try to solve LeetCode problem 253, meeting rooms 2. So before we jump into this problem, we can do a warm-up problem, which is meeting rooms 1. So in the meeting rooms 1 problem, we are given an array of meeting time intervals consisting of start and end time. For a particular meeting, its start time SI is always less than its end time EI. So we are asked to determine whether a person could attend all the meetings. So we are given two examples. In the first example, we are given three intervals: 0 to 30, 5 to 10, and 15 to 20. And the output of this example is false, indicating that person couldn't attend all the meetings. Why? Let's take a look. So three intervals are given in the first example. The first one is from 0 to 30. The second interval starts at 5, ends at 10, and the third interval starts at 15 and ends at 20. So you can see there are some overlappings between these three intervals. In another word, if that person attend the meeting 1 at this particular time, then that person won't be able to attend the meeting that starts at 5. Similarly, if that people attends the meeting starts at 0 at this particular time, then that person won't be able to attend the meeting starts at 15. That's the reason why example returns 4. In the second example, we are given two intervals. The first one starts at 7, ends at 10, and the second interval starts at 2 and then ends at 4. So we can see there's no overlapping between these two intervals, so the person can go to the meeting that starts at 2 first, and when the meeting ends at 4, he or she can go to the second meeting, which starts at 7. That's the reason why the second example returns true. Right, so now we need to design an algorithm to solve this problem, to determine whether a person could attend all the meetings which are given in this input array. An intuitive idea is we basically sort all the intervals by its starting time. Okay, and when a new meeting comes, that's highlighted in red, we just need to compare the start time of the new meeting with the end time of the previous meeting, right? If the start time of the current meeting is smaller than the end time of the previous meeting, then we know there is a conflict and that person won't be able to attend these two meetings. If the start time of the new meeting is greater or even equal to the end time of the previous meeting, and then the person can go to the two meetings, right? And let's solve this problem. Let's do some input check. If intervals is not valid or it has size 0, we simply return true because we won't have any conflicts. Okay, then we need to sort the array, the intervals array, by the starting time. Right, and then we just check every two meetings one at a time. So for the first meeting, we don't need to check it because we know there is no previous meeting, there's no conflicts before. So we start from the second meeting, which has index 1. Right? If the current meeting's start time is less than the end time of the previous meeting, we know there is a conflict and return false. This is start time. This is the end time of previous meeting. If this is the case, we return false. If not, at the end, we return true. The answer is wrong. If the current time's start time is less than the end time of the previous meeting. Okay, let's submit it. So as you can see, the runtime is pretty good. For the sorting part, it takes a log(n), which is the number of intervals in the intervals array. And the second part here is just a linear search. We have a big O n time complexity. So overall, the time complexity is dominated by the sort method, so which is a log(n) time complexity, right? So now let's take a look at the follow-up question, meeting rooms 2. So given an array of time intervals consisting of start time and end time, and for any particular meeting I, its start time SI is always less than its end time EI. So instead of checking whether a person could attend all the meetings, in this problem, we are asked to find the minimal number of conference rooms required to hold all the meetings. So we are given 2 examples here. And in the first example, similarly, we are given 3 intervals, 0 to 30, 5 to 10, and 15 to 20. Okay, so we can reuse this diagram. So these are the 3 intervals given. So what the minimal number of conference rooms are required in order to hold all these 3 meetings? The answer obviously is 2. Why? Because we need 1 meeting room to hold this meeting starts at 0, and then we need the second meeting room to hold the meeting starts at 5, but then when the third meeting starts at 15, we can reuse the second meeting room, right? We can reuse the second meeting room, right? Because the problem is ask us to find the minimal number of conference room, so we don't have necessarily to assign each meeting a conference room, right? And in the second example, similarly, what we need is we can only use 1 meeting room. We first use that meeting room for the meeting starts at 2, and when that meeting ends at 4, we just reuse the first meeting room to hold the second meeting, which starts at 7. Right? So these are the 2 examples. So now we are asked to design a generic algorithm to find the minimal number of conference rooms required in order to hold all the meetings. So how can we do that? So now imagine that you run a hotel that there are customers check in and check out daily. So in order to keep a low operating fee, you want to use as minimal rooms as possible. Let's assume using any additional room will increase the operating fee. In order to achieve such a goal, an intuitive idea is to you make full use of the rooms you have as much as possible. In another word, when a customer checks in, you will prefer to reusing a room that was taken by another customer than assigning the new customer a new room, right? Let me demonstrate what I mean. So let's say you have a hotel somewhere. Okay, you have a hotel somewhere. And every day you have customers check in and check out. Okay. Let's say at a certain time there is a new customer wants to check in. So at this point, you want to use the minimal room to serve all the customers, right? So you basically have two options. One is to give this new customer a new room, but that will add your costing, operating fee. The second option is if there is any customer has checked out before the new customer comes in, then we can reuse that room to serve these new customers. Right? So similarly, in order to use minimal number of conference rooms to hold a certain amount of meetings, we just need to reuse the conference rooms as much as possible. So when we schedule a new meeting, we need to check whether there is any conference room was used before but now is released. If there exists such a conference room, then we just reuse it. Right. So now the problem becomes, how do we know whether there is a room available to reuse? Right? I think we can use two arrays to store and sort the start time and end time separately. So when there is a new meeting needs to be scheduled, we basically compare the meeting's start time, the new meeting's start time, with the next available smallest end time, which will indicate the earliest time that we can have a room, conference room to reuse. What do I mean? Let me demonstrate it. Let's say we have a new meeting to be scheduled. Let's first mark some end time here. Okay. And now we have a new meeting comes. We need to schedule it. Okay. Let's say the end time 1, E1, is our next available end time. Then we will have a room to reuse. Why? Because when the new meeting comes, right, the start time happens after the end time, which means that room, conference room, was occupied, now is released, can be reused. But if the new start time is less than the E1, So basically means we have to assign a new conference room to this new meeting because there won't be any room available to reuse. Right. So this idea may be confusing because it will break the correspondence between the start time and end time of a meeting. Yes, it is, but it won't impact the result because like this hotel example here, where at the time we need to decide whether we need to reuse a room or we need to assign a new room to the new customer. We don't have to track the check-in time and check-out time for every customer. All that matters is whether and when there will be a room can be reused, right? So in our example here, we can separate the start time and end time, use two arrays to maintain them. And then we can implement a solution based on the two arrays. Now let's code it. So similarly, we do some input check. If intervals is null or has size 0, we just return 0 because we don't have any meetings to hold. And then we need to maintain two arrays. One is used to maintain and sort the start time, and the second one gonna be used to maintain and sort the end time. Starts. And then we have the second array that's called to ends. Okay, we need to fill in these two arrays first. We put all the start time into array starts. And we put all the end time into the end array. Right, and then what we do is we just sort the two arrays. By its value. Okay, so after sorting these two arrays, what we do is we just iterate the intervals, right? Every time when a new interval comes, we just check whether we have a conference room is available to reuse, right? So let's do that. We first need a counter, which will be our result. Let's initial the counter as 0. And we also need an indexer to indicate what is the next available end time. In other words, what is the earliest time we can have a room to reuse, right? And then we just start from the first meeting, the meeting intervals, and do some checks. Right? As I mentioned before, there are two cases. What are the two cases? When a new meeting room comes, this is not necessarily to be 1, it could be any number, let's say I. Okay, so if there is an end time that is greater than the start time, right? I should say this. When the earliest end time is greater than the start time, we know we won't have any room to reuse. In this case, we have to assign a new conference room. But if there is an end time that is smaller than the start time of the current new meeting, then we know we can have a meeting room, conference room to reuse. But after we reuse this room, we need to update the next earliest end time, right, for the next meeting's schedule. So let's implement the logic here. If the earliest end time will be is smaller or equal to the start time of the current new meeting, then we know we can reuse that room, but we need to update our end time, the earliest end time, right? If not the case, we know we need another conference room. Eventually, we return the counter. Let's put some comment here. Then we can reuse a conference room. Right, otherwise we need to assign a new conference room. Let's compile the code and submit it. And so as you can see, I've worked on this problem many times. It's a really good problem. And the idea behind this solution is a little bit tricky because you have to break the correspondence between the start time and end time, right? So it's not very straightforward. And in terms of the time complexity, you can see this part here is just a linear search, which takes big O(n), and but we have to do two sorting here, which takes n log n, 2 log n, right, n log n, and then this part is also a linear search. So it's dominated by the sorting time complexity, so which is n log n. And space complexity, we create two array to maintain the start time and end time, and it's going to be a big O(n) space complexity. Yeah, that's it. That's the solution of this problem.